Hello all. Thank you for coming to this production of Romeo and Juliet, A Calculus Tale, produced by our friends over at Plus C or Not Plus C Studios. We would like to take this opportunity to thank our producers for providing funding, but also our amazing audience for allowing the show to happen.
Yes, thank you. I'm the stage manager. Is that it?
Now let's take a moment to talk about the amazing crew that made the show possible.
Hello, my name is Pema Kennedy, and I work to make the stage come to life through realistic props. I'm the head of the props committee, and this right here is the props table where actors can grab props before they go on stage. Just take a look at this door. We call this the derivative door, because in order to turn into a door, we must take the derivative of the graph y equals negative 1/3 x cubed. The derivative of this turns into y equals negative x squared, or visually, an arched doorway. And that's the beauty of props. Thanks for coming along with me. Now we're going to go to costume.
Now we're going to meet Augie in the costumes cage.
Welcome to the costumes cage. I'm Augie, I'm head of the costumes department, and we help to make the actors really become their characters. Here is a conceptual design of one of the costumes. We can find the area under the curve of this hoop skirt by using the Riemann-Sun approximations. Here's how the design looks when graphed using midpoint Riemann-Sun approximations. We don't need to be exact, but we need to know how big the skirt will look on stage. Thanks for coming with us to the costume cage. Now on to lighting and sound.
Now we're going to meet Emma in the tech booth.
Hello, I'm Emma. I'm the lighting crew, and a huge part of the set is setting the mood of the scene. We can do this by changing the lights, increasing the light pool or decreasing the light pool. T. The light works down in a conical shape, where it points down and creates a circle on the ground. We can use relative rates to find the rate of change of the area within the cone as the light increases in size.
So if we're talking about the rate of change of a light, we know lights work in a cone, which makes a circle on the ground around you. So if we know the radius of the circle is 2.25 meters wide, and we know dr/dt, the rate of change of the radius, is 0.75, we can find the rate of change of the area of the circle by knowing area is pi r squared, taking the derivative, plugging in dr/dt, and then getting our final answer of 3.375 meters squared per second.
Thank you for coming with me to the tech booth, and now we're going to hand it back to the stage manager on stage.
Now that you've gotten to meet some of our tech crew, now it's time to see their work in action.
The actors have worked very hard to put this production together, so we hope you enjoy Plus C or Not Plus C's production of Romeo and Juliet, A Calculus Tale. Juliet's so perfect. It's love at first sight.
What does that even mean? How do you know she's the one?
Well, she's pretty, she's cool, she's attractive, she dresses nice, she's beautiful. She's the one girl I can never have.
Right, a real catch.
What time is it?
It's 6:15.
No! The ball is 12 miles away and it's at 6:30. How fast can your wagon go?
Oh, not this again. Sounds like a calculus problem.
Okay, so, this is like an A-rock problem. So we had displacement over time equals average velocity. So we know it's 12 miles away and it's gonna take, and we have 15 minutes or a quarter of an hour. So if we take 12 miles and divide by 0.25, we get 48 miles per hour.
Man, our carriage is gonna go so fast.
Phew, glad we figured that one out. Wow, this place is so cool. I wonder if anyone will recognize me.
We won't know until we go inside. Who's that at the door?
Who are you and what do you want?
In order to prove you're of high enough status to enter the Capulet Mansion, you must first solve this riddle. Take the antiderivative of this equation and revert it to its original form. Only then will I know your true of heart.
Here we go again.
Okay, we have to take the antiderivative of this equation. This means reverting it back to its original form. Marquisio, my marker!
One eternity later.
Phew, finally got that done. But is it plus C or not plus C?
It's definitely plus C.
You're so right.
You may pass. I have looked into your soul and found no danger.
Okay, thanks, totally not Romeo.
Yeah, I mean, who even names their kid Romeo? Sounds like a stinky Montague. Look, Mercutio, there she is. She looks so wonderful tonight.
Go talk to her.
But how could I possibly charm such a beautiful, wonderful, amazing, pretty, nice, attractive girl?
Romeo, girls are obsessed with calculus nowadays. Just woo her with your calc knowledge.
You're so right. Hey, Juliet.
Romeo!
Capulets are red, Montagues are blue. You must be discontinuous, because I'm on the cusp of falling for you.
Oh, Romeo, calculus fun. I think I'm in love with you.
3 days later.
Romeo, Romeo, wherefore art thou, Romeo?
Juliet, don't be so loud. I'm down here.
OMG, Romeo! Quick, get up here. Use the ladder so my parents don't see. Oh no, the ladder!
Oh no, ladder fell. It's like one of those calculus problems. Oh man.
Romeo taught me calculus. How can I do this calculus problem? So, here is Juliet, here's the ladder, and here's the floor. The ladder is 40 feet. We need to find A, and we need to find the velocity of A. So, we do the Pythagorean theorem, and we get A equals 32 feet, and then we can put it in this equation to find dA dt, which is equal to negative 2.25 feet squared per second.
I can't believe the ladder fell. Maybe that's a sign we shouldn't date each other. Nah.
3 weeks later.
Oh, Romeo, I'm totally gonna fail my calc test tomorrow. Since you're such a calc mastermind, can you help me with my project?
Fear not, Juliet. To the classroom.
Okay, so when you have product rules is when you have two functions such as f of x and g of x. So what you do when you want to take the derivative is you start with the derivative of the first function times the second function, and then you add the first function times the derivative of the second. But when you have a chain rule, that's when you have a function nested inside of another function. So what you do here is you start by just taking the derivative of the outside function, and then you multiply that by the derivative of the inside function. So if you had something like sine of x, sine of 3x, you would take the derivative on the outside. So you start with cosine 3x, and then you multiply that by the derivative on the inside, which is 3x. So you end up with cosine 3x times 3, or 3 cosine 3x. There you go. Now you won't mess that part up on the test.
Oh, Romeo, what would I do without you?
A few moments later.
Romeo, I got a 75% on the test. I passed. Thank goodness the teacher curved it.
Juliet, I have a confession. I got a 50 on purpose so that the teacher would curve the test because I wanted you to pass.
Oh, Romeo, I can't let you fail alone. I'll tell the teacher I cheated so I'll fail too.
Many months later.
Romeo and Juliet both ended with an 89 in calculus. They both had to take the final.
The end.